I was hired at Netscape in April 1995. Netscape had already launched its 1.0 Mosaic killer. If you remember, Mosaic was the big, NCSA Mosaic was the big browser until Netscape took over. So when I came to Netscape, they'd been going for about a year. I actually had an option to go in at the beginning and I passed it up. But I went in time to do what I was tempted to do, which is a programming language for HTML for web designers and programmers to use embedded directly in the web page, not something that was like coming along at the time called Java, which was more of a professional's language where you would write real code with type declarations, and you'd have to write that code in a way that compiled. I was writing something, JavaScript, that could be used by people who didn't know what a compiler was. They were just going to load it. It was like BASIC. And that was really the pitch, that we would make two languages, not one, analogous to Microsoft's Visual Basic for C++. So JavaScript for Java. Bill Joy of Sun actually liked that idea and agreed with it, and he was the guy that signed the trademark license by which what I had created became JavaScript. The name is a total lie. It's not really related to Java so much as to a common ancestor, C, in syntax. And to the extent that we made it easy to use and something you could copy-paste program or start small from scripts and grow to programs, JavaScript has succeeded massively. It was also an incredible Rust job, so there were mistakes in it. Something that I think is important about it is that I knew there would be mistakes and there would be gaps, so I made it very malleable as a language. And that has enabled web developers to make it be what they want it to be, to project their own style of not just API, but almost language pattern on it. And create their own innovation networks, to use Eric von Hippel's phrase, or innovation toolkits on top of it. So it's not a language that tries to restrict you to one paradigm. It's a multi-paradigm language.
I mean, there's all these things where a language comes out and immediately trips and falls, and you have to sort of, it's okay the second time, but there wasn't really a trip and fall in JavaScript. Why? So
you could say that there hasn't been a version 2, and that's true, because I've tried to work on what might be a big version 2. That was called the 4th edition, and that failed. There has been evolution. The web is all about evolution. People don't quite see this while you're in the midst of it because it's microevolution, but web pages from the 90s don't all render properly these days. They don't all work right, and a lot of them are lost and only available through webarchive.org. JavaScript had enough at the beginning, enough good parts, to use Crawford's phrase, or enough genetic material from other languages. First-class functions, prototypal inheritance from self. The inheritance of first-class functions from Scheme is really kind of a fraud, because Scheme is different in many ways, and I couldn't make those differences manifest. I couldn't do the Scheme thing in JavaScript. I was under these marching orders to make it look like Java. I had 10 days to prototype it. So Scheme was more of a spiritual than an actual influence. But first-class functions are very powerful, and they fit with an event handling sort of programming model. I was inspired by Atkinson's HyperCard. So that's why you see on-click in JavaScript. HyperCard had this pattern for event handlers called on page, down, or whatever. So JavaScript had enough good at the beginning to survive. Now, if you think back, though, to the mid-90s, JavaScript was cursed because it was mainly used for annoyances like little scrolling messages in the status bar at the bottom of your browser, or flashing images, or things that popped up windows massively. We could have put in controls for those, and we should have. Eventually, browsers, Firefox kind of championed this, led this automatic suppression of annoyances that made it all much better. And with Moore's law compounding, and with JavaScript getting some evolutionary improvements in the standards process, it became really quite fast enough and good enough in 2004 and 5 to beget the Web 2.0 revolution. That was, I think, tied in with Firefox's retaking market share from IE and developers realizing there was a client side to the programming stack that could be expressive and powerful and could be fast enough thanks to faster computers, mainly.
You must have had some training, some kind of
I'd done a lot of
set of experiences that kind of got to the point where you could pull from Scheme and
I had implemented, I was sort of a language buff when I first entered computer science. I was a physics major originally and ended up math computer science when I finally got my undergraduate degree. So I was programming formal language theory applied to recognizing languages, like lexical analysis, parsers, automatically constructed parsers from grammars. I love that stuff because it was all very pretty and clean theoretically, and it still is. It hasn't changed a lot. There's been only one or two innovations since my time in university in the early 80s. So what that gave me was the ability to quickly knock out, a sort of a language interpreter. I could do the parser and the scanner. I could generate bytecode because Netscape wanted to do a server-side embedding in JavaScript, even though it could have been a tree walker or something that interpreted parse trees. I made a bytecode for it, and it was an internal bytecode, not the Java bytecode that's become a handicap for Java, I think. And I knocked all that out really quickly because I'd done it before. I'd done it at Silicon Graphics to build sort of network monitoring tools to capture packets based on expressions over fields at the various protocol headers. I'd done it for fun just to make my own languages. And finally, I got to do it really quickly. The speed was an issue for me. It was partly, we were all feeling like Microsoft was going to come after Netscape because they had tried to buy Netscape in late '94 for too little money. I'd heard about this before my time at Netscape. But we also were in a weird game theory with respect to Java because even at Netscape, some people thought, well, if we have Java, do we really need a second language? They didn't see the benefit of the Visual Basic companion language for a much larger cohort of programmers or amateurs, designers, beginners. To write Java as to write C++ for the Microsoft platform today took a lot of education and greater pay. It was a higher price proposition. To get people gluing components together and designing pages and filling gaps using JavaScript as they did with Basic and Visual Basic and Microsoft's Windows was cheaper and wider spread. It also enabled this user innovation toolkit approach, to use Von Hibbel's phrase again. Because JavaScript was malleable, because there were so many web designers, you would see different schools of thought on how to use it emerge. And this has become quite clear over the last 10 years with the various JavaScript libraries. And I think that's actually an advantage, as I said earlier, to JavaScript, that we're not telling you, here's the one way to write it. Here's the one true object-oriented paradigm. Here's the only way you should ever make a reusable abstraction. It's not unmixed, right? It's hard for beginners. People reinvent certain wheels and make mistakes doing it or don't like having to acquire a library. But you see jQuery, a very popular library, because it gives people this very sweet query and do paradigm. And again, it's not mandatory with JavaScript, but a lot of people learn that and they think that is JavaScript. They think jQuery is a language, or they think, jQuery is the tail that wagged the dog. jQuery is great, and John Resnick used to work with us at Mozilla, but there are so many good libraries out there now, and they're actually shrinking and becoming more compositional, which is a good trend. So JavaScript, by being malleable and sort of fostering user innovation, I think has played a unique role. If I had done something more rigid, I think the odds are greater it would have failed.
I just can't imagine how you would have escaped from the object-oriented pattern of C++.
Partly I had to, because if I'd done classes in JavaScript back in those 10 days in May in 1995, I think I would have been told this is too much like Java, you're competing with Java. Somebody at Sun would have yelled at Bill Joy more than they did, and it might have killed the deal. So I was definitely not only under time constraint, but under marketing orders, make it look like Java, but don't make it too big for its britches. It's just this sort of silly little brother language, right? The sidekick to Java.
But then you put in primitives.
I snuck some stuff in, yeah.
You put some primitives, like closures and all those other things that it's like you can build what you want.
Yes, and that kind of went under the radar for a lot of people, and it wasn't all even there in a good working order in the first release. But over the next few years, it became not only well known, I would say more standardized and well known. Over the next 10 years, it became evangelized, like Crockford's a big exponent of the closure pattern and the good uses you can make of closures. So people find the malleability and the expressiveness and the power compelling enough that some people actually resist any version 2. They say, I don't want you to add cliches or common special forms for patterns that I'm more happy writing myself or acquiring as a library myself.
You've created an abstraction that implementers can do crazy things with, right? And people can rethink what the interpreter is really supposed to do.
They can.
And they can just say, okay, here comes V8. And we thought about a lot of things differently, right?
Optimizations that haven't been tried. I knew about these optimizations because I'd studied Smalltalk itself, but nobody had gotten the time and the money. Google was maybe first. There were other efforts going on in parallel, and Apple and Mozilla have kept up as best they can. But V8 deserves a lot of credit for pushing this forward. It wasn't quite as first on the scene as they like to claim, because it was all coming together in 2008, but it has been very helpful, and it has shown people what can be done. What's interesting to me is that you then go and put different, more intensive workloads on the language, and you see there's a new V8 that should come out of somewhere. It may not come out of Google because they may have tired of optimizing JavaScript. In fact, I believe Dart is a response to that by the principals who did V8. They want to do a language where they don't have to worry about all this crazy compatibility. May not succeed, and it also doesn't give JavaScript the next level of performance. But I believe that level is there, and it's still improving in performance much more dramatically than a language like Java, where the gains are a percent or a fraction of a percent on the standard benchmarks. But a lot of HTML5 development now, quote unquote HTML5, JavaScript, CSS, web APIs, beyond what's in HTML5, is taking off. You're seeing like Zynga doing HTML5 only games. It's really coming faster than some thought. And I talked to venture capitalist Fred Wilson of Union Square in New York, said, yeah, it's here. He thought it would take years. We've turned that corner. And so you call it HTML5, what it really means is it's the web stack. It's the same stack you use to write web pages and hosted web apps. You can write apps that run in your device, apps that are maybe hosted, maybe offline, maybe the line is blurred so that you can associate them with a URL, but you can also take them on the plane without any fear that you're going to lose anything by disconnecting from the internet.